Today we have here joining us inside the International Space Station Flight Control Room, we have NASA's Project Executive for SpaceX, Mike Horkachuck. Mike, thank you for joining us and welcome.
Thank you.
So Mike is here actually to give us an update. We've been talking about some of the removal and replacement of the failed GPS on board the International Space Station, and he's here to give us an update on SpaceX launch and also on that GPS. So first of all, can you give us just tell me a little about yourself and how you came here to NASA real quick before we get into the update.
Okay. Actually, I started out at NASA in Ames Research Center, and then I transferred here to JSC about the time that Space Station Freedom was being repositioned and renamed to Space Station Alpha, and been working in the Space Station office for over 10 years. Did a little time in the Constellation program in test and verification, and then I've been working in the COTS office as the project executive for SpaceX for at least 5 years now, since end of 2006.
Okay, for a while now. So tell me real quick, just what is the update? What is launch looking like right now?
I think launch is looking good for the 19th. It's early morning on the 19th Cape time, 4:55 in the morning.
4:55, so 3:55 Central Time.
Correct.
And so everything looks good for that. Now, let's go ahead and talk about that GPS, because I know that for the attitude control system aboard the International Space Station, there are two, and it is necessary that both of them are working in order to do the rendezvous and docking with the Dragon. So if you can just tell me a little about that.
Yeah, we had a launch constraint that we want both systems up and operating for redundancy. So before we give the go to launch, we wanted both systems up and running. The whole rendezvous process uses GPS as part of the sensor suite for the rendezvous, and as you start getting closer to station, you want to do what we call relative GPS. So we're sending data from the space station on its position from those GPS sensors through a communication system that SpaceX developed called the Cuckoo. It's a UHF communication system to the Dragon spacecraft. And then it uses that data plus the GPS data on board the Dragon to look at the relative position of the two vehicles, so that the two vehicles don't get too close to each other, and we know exactly where they are.
Okay, great. And anything new we're just on target for launch? Everything looks good, nothing new?
Yeah, I think we closed out a lot of work over the last couple of weeks. There was a lot of software that's been rechecked and validated by the space station program. They did a end-to-end test of the data system, as well as another stage test, checking all the software functionality as it relates to space station. Looked at a lot of the changes that have been done on the software and gotten comfortable that all those changes were acceptable. The hardware has been in pretty good shape for the last few weeks. We did a static fire about 2 weeks ago out at the Cape, and the first stage engines performed fine. All that data looks good, and the Dragon spacecraft's been closed out for flight for quite a while.
Okay.
So I think things are looking good.
Good to go. So real quick also, tell me about I know that at times when we have launch, we have this whole, the weather and that sort of thing. If something were to happen and weather does not cooperate with us, is there a second chance opportunity to...
Yeah, there's another planned opportunity on the 22nd.
Okay.
It gets a little bit earlier in the morning due to the phasing, trying to catch up to space station. And then after that, there's about 4 more opportunities before we get into a high beta period, where it's just not going to be good to fly up to the space station for rendezvous.
Okay. And are those 4 other opportunities, are they consecutive each day, so on the 22nd and then after that, or are they set dates for later?
Yeah, they're set days. They're staggered a little bit,
okay.
And it depends on the orbital mechanics. I think it's the 23rd, 24th.
I'm not going to hold you to it, but
yeah.
I just didn't know if it was consecutively right after the 22nd.
Yeah, and then we'll need to work with the range,
sure.
the Air Force, to make sure that those days are available, and just kind of plan it out.
Okay. So now, how involved has NASA been with the development and the pre-flight test and that sort of thing? with SpaceX? I'm assuming pretty
Y-
much involved as you were talking about, but what was your experience and
Yeah,
what?
as part of the Space Act agreement, we've been looking at milestones since the very beginning of the development program. We started out with an initial kickoff meeting and then went into what we call a preliminary design review. We had a number of NASA engineers looking at the preliminary concepts of the design, just
Mm-hmm.
the high level. And then we proceeded into critical design reviews as well as detailed reviews of various testing events that had gone on. As they were building up, they started testing the Draco engines on the Dragon spacecraft up in McGregor. They incrementally did testing of the first stage. They actually lit the entire first stage and ran a full mission duration at their test facility in McGregor. Um, we did a large system thermal vacuum test where the whole spacecraft was in a thermal vac chamber, checking out the extremes of temperature and making sure all the systems function during those extremes. EMI testing. We did what we call a DRR, Demo Readiness Review, which looked at all the qual and acceptance reports, and we did a top-level look at all those and made sure that they had met their criteria for launch vibration, shock environments, temperature, um, the usual kind of things that we do on a spacecraft.
Okay.
So we've been involved. I wouldn't say that it's necessarily as deeply as involved as we've done on some other projects, but it's been a good review.
Pretty
And then
involved.
they've gone through all the safety review process with the space station, so it's been a
Sure.
very thorough
So
review.
lots of collaboration,
Right.
collaborative work between SpaceX and NASA as well. Now, with SpaceX, it takes a lot to build a spacecraft, it seems. But so if you can just go through just the why. Why are we looking to commercial industry to help us, develop spacecraft?
Well, there's been a push, I guess, that NASA's been doing flights to low Earth orbit for a long time now, 40, 50 years since Apollo, and we've kind of got the technology down, and it seemed like it was mature enough to pass on to U.S. industry. And the idea was that if we could get commercial industry to start doing it, um, it would turn out to be cheaper in the long run,
Mm-hmm.
and it would give more of the NASA budget the opportunity to be looking at building spacecraft where we can go deeper and further into space than we ever have before. Go on past the moon, out to L2, out to asteroids, and potentially in the long run get to Mars. So it gives us an opportunity to use our budget more efficiently.
Mm-hmm.
I think is the real benefit of going commercial
Sure.
right now.
And so while we're not just after the cheaper ride, we also are seeking for reliability. Is that correct?
Oh yeah, we definitely want the systems to
Yeah.
work, and that's one thing that when you hear cheaper, you're sometimes thinking that it's going to be less reliable.
Mm-hmm.
I know for a fact that SpaceX is very focused on trying to make sure that their systems work. They know that as a company, they have to make their products successful, or they're not going to get new business. So they're very focused on making sure that their systems will work and that they have high reliability built into the systems. They may go about doing it a little bit different than we have in the past, but it's always in the back of their mind that they have to make these vehicles work, or they're not going to have a long-term viable company. So in some cases, it's even more important to them that it's all successful than other companies
Mm-hmm.
on a typical
It is
FAR-based
it is
contract.
its own company's livelihood to
Correct.
make sure that it is reliable as well. Now, so do you know? Can you tell me the contents of SpaceX? I mean, first of all, what is the cargo capacity, and then what is it going to be taking up to the International Space Station?
Okay. Well, not on this flight. The total cargo capacity is on the order of 3,000 kilograms. On this flight, we're taking up about a little over 500 kilograms up and about 600 kilograms down. Um, in general, it's lower value cargo, food, crew supplies. There's a small number of science experiments that are going up. Um, in general, this is still a test flight. We initially had 3 test flights in the development program under COTS. The first one we flew December of '09. Very successful flight, launched out of Cape Canaveral. got the Dragon spacecraft into orbit, circled the Earth 2 times, proved that the basic thrusters and guidance and control system would work. It pointed at TDRS, and then re-entered and proved that the heat shield and the whole re-entry system worked well, and the parachutes deployed well, and it was a very gentle landing in the Pacific about 3 hours later. Then we were going to gradually increase the complexity of the missions. The second mission was supposed to do a flyby a station and check out some of the aborts and kind of maneuvers that might be necessary on a mission going to station, as well as closing the communications link between the space station and the Dragon spacecraft. And that was the primary objective of that mission. Then the third mission would have actually been a full rendezvous and berthing with the space station. After a lot of review, we've decided that we can let SpaceX make an attempt at doing both those objectives on this mission. And that's why we've redesignated it as a C2 plus mission. It's the C2 basic mission, and they're going to try and get some of those bonus objectives of the third demo. So we're trying to give them the opportunity of meeting all those milestones, and then if they are successful, they can move on to the operational phase where we'd be flying more valuable cargo up to the space station on a regular basis.
Yeah, so you're touching base on something that I wanted to talk about. So the just space operations in general, how do you see, what is the significance of SpaceX, this being a successful launch and docking to the International Space Station, and then also how do you see the evolution of space operations after that, within the next decade?
Okay. Well, I think this is a important mission, but it is still a test flight, so I have to caveat all our statements that, this is a checkout flight. There's a lot of things that could go wrong. We've done a lot of work on the ground and a lot of testing to try and make sure that things work, but invariably once you get into space, something doesn't work the way you necessarily thought it was going to work. So we'll look at the data and see how the mission went, and then decide if we need another test flight or we can move on to the operations phase. Longer term, I expect that we're going to go into a full operational phase. We'll go find if there is a problem, we'll find what the problem is, go fix it, and go fly again. And then we'll get into long-term operations where we're taking cargo on a regular basis up to the space station. Ideally, we'll be moving on to commercial crew over in the next decade. Some of the timing of that I think is going to be somewhat dependent on congressional funding and how much money they give the program to develop the commercial crew capabilities. I'd like to see us eventually having a regular commercial crew capability where we're launching astronauts from the U.S. up to the space station on a regular basis. And then I think in the longer run, we're going to be flying deeper and further into space on some of the NASA vehicles on a Orion spacecraft and going on out into space to L2 and asteroids, and hopefully doing some real serious planning for a Mars mission.
And contingency planning, is there any kind of contingency if something were to go wrong during for this particular launch, since it is a test flight?
Yeah, we've worked out all the contingency plans with all the various agencies. Since it is a commercial flight, the FAA has a lot of authority, and they have the primary role with the NTSB to investigate a launch failure. Depending on when in the mission it happens, there may be some support from the range, the Air Force. As it gets close to station, it would be primarily the space station and NASA's role to investigate any mishaps. So we've got a plan laid out for all the phases of the mission and who's got primary responsibility. I think in all cases, our office would be closely coupled with SpaceX doing the investigations.
Great. Well, thank you again for coming. It's all very, very fascinating. Best of luck. I know you're leaving us tomorrow, correct, to head to the Kennedy Space Center where the launch will be taking place?
Yeah, we have a flight readiness review, a Delta flight readiness review in the morning tomorrow, and then I leave for the Cape, and then we'll have a launch readiness review on Thursday, leading up to the launch on Saturday.
Great. And again, that SpaceX Dragon launch is set to take place at 3:55 a.m. Central Time. That is on May 19th. That is a Saturday, and we will have live coverage here for you on NASA television beginning at 2:30 a.m. Central Time. Again, thank you, Mike, for coming, and best of luck,
Thank
and
you
have a
very
good
much.
trip.
Thanks.